Good morning, everyone. This is lecture number 5, and we are dealing with speed and velocity. I think in the previous class we had dealt with the different types of speed. Yes or no? Do we remember it? Do we remember what we had done in the previous class? We were dealing with the types of speed. What are the types of speed that we have discussed? Great. The first one was uniform speed, body moving equal distances in equal intervals of time, constant speed. Then we had variable speed or non-uniform speed, unequal distances in equal intervals of time, speed keeps on changing. Then we had seen what do you mean by average speed and what do you mean by instantaneous speed. Average speed is always calculated over an interval of time, whereas the instantaneous speed means the speed at this point, at this time. Whenever we say the word speed, we are referring to the word instantaneous. I mean, we mean instantaneous speed. Yes or no? Do we remember this? Now, we must go ahead and solve some questions on this so that I can log this topic and we can move ahead. So, we will solve some questions on this so that this topic remains with us forever. Remember, bacha, whenever a question comes to you, if you remember the definition of things, that question becomes simple. If you don't remember the definition, you will feel confused. So here comes the first question, and the first question literally says you have to find out a car is covering 2/5 of the total distance with a speed of v1. 2/5 of the distance is covered with speed v1 and 3/5 of the distance is covered with speed v2. What is the average speed? Okay, just let me know. I had sent you what dpps and practice sheet. Did you get it? One center got it, the other one did not get it. Okay. Life is good. Life is good. All is well. Don't worry. You will get it. Uh, the more the practice you do, bacha, the better it is for our health. When I say our health, I mean our padhai wala health. So how are you going to do this question? Remember, first tell me. Now, since you are a JEE wala student, is this question necessarily question of one dimension or it can be a question of 2 dimension or 3 dimension? Since car is moving, is it necessary that it should move along in a straight line for this question, or it is possible that it can take a turn, go up and down also? What do you think? Is this a question of motion in 1D or this could be a motion of more than 1Ds? Yes, I'm waiting for your answers. Is this a question of 1D or can this be a question of 1D, 2D or 3D? As the case may be. Yes. No one knows the answer? A car covers 2/5 of the distance with a speed v1. When nothing is said about the speed v1, we will assume that this is uniform speed. Do we understand this? When nothing is said about this speed v2, we will assume that this is also uniform speed. I again repeat my question. Is this necessarily a question of motion in 1 dimension or this could be a question of more than 1 dimension as well? Yes. Either it's a yes or a no. This is a yes, sir. This is a question of 1D. It's a no. No, sir. It can be a question of more than 1D as well. Yes.
Sir, 1 dimensions.
No, it can be a question of more than 1 dimension. Speed has got nothing to do with direction. It can go anywhere. So if I ride on a bike and I keep my speedometer at 50 km/h, I can go up, I can go down, I can go here, I can go here. this question is valid, whether it is 1D motion or 2D motion or 3D motion. So remember, the heading of the chapter may be 1D motion, but whatever we are doing is not restricted only to 1D motion. Do we understand this? Okay, now comes the question. How many of you went through the last class before coming to this class? How many of you went through the notes? Only, okay. Then if you have gone through the notes, then I think you must be able to do this question. So I have given you enough time. Are you able to do it, or you want more time? The answers are not important. The important aspect of this class is you understand what you are doing. When you try, once you try, answers are going to come one way or the other way. Shall I help you out, or you will be able to do this? Options are there. Shall I do it? Shall I do it, Bacha? Okay, so how are we supposed to do this? Okay, I'll give you 1 more minute. I think you can. You're trying, so I must give you time to try. Average speed we have to calculate. Can anyone tell me what is the
Total distances by total speed.
total distance divided by total time? Well done.
Yes.
Now remember, in any question that comes, the first thing that you have to do is what? Is to draw a simple diagram. Because without a diagram, things look pretty bad in physics. So here is a simple diagram I have drawn. I have told you that this may not be a motion of one dimension, but if I draw a zigzag path, that will not make much sense. So I'm just drawing a straight path. So he starts from point A and he lands up at point B. The total distance, I have assumed it is not given how much is the total distance. So I've assumed that this is equal to L. Do we understand this? Then 2/5 of the distance. So let me make a point here somewhere. This from A to C is 2 by 5 times of L. I hope we understand this. And from C to B, it would be remaining 3 by 5L. I hope I am not making it complicated. Yes or no? So this 2/5 of the distance, he moves with a velocity v1. The rest of the distance, he moves with a uniform velocity v2. Yes or no? Do we understand up till here?
Yes, sir.
Now, I don't know what is the time taken. So let me call the time taken as t1 in this case. and the time taken as T2 in this case. So far, so good. So whatever I had known, I have written it. Whatever was unknown, I have also written it, assuming it to be L, X, A, B, C, D, or whatever. I have to find out the average speed, and the formula for average speed is total distance. Total distance is L. How much is the total time? Everything is there in the diagram. Once you make the diagram, the question is 95, 98, 99% done. In this case, it is almost 100% done. Yes, how much is the total time?
T1 plus T2.
Well done, T1 plus T2. Now, the only thing is, I have to get the values of T1 and T2. To get that value of T1 and T2, I have these three quantities. Now, these three quantities will give me the value of T1, and these three quantities will give me the value of T2. Remember, I have assumed that the speed is uniform. Can anyone tell me from the yellow quantities, what is T1 from here?
Hello, good morning, sir. Hello.
Yes, beta, tell me, what is T1?
Sir, T1 equals to 2 by 5 by V1, sir.
2 by 5 L, you have forgotten, bacha.
L by V1, sir.
Yes, that is T1. How did we get this? We just applied the simple formula of uniform velocity.
Yes, sir. T2 equals to 3 by 5, 3L by 5 V2, sir.
Similarly, we have T2 as 3 by 5 L by V1. Do we all understand this? Everyone in the class? You just put these values here. You just take both of these values, put them here, which I am not going to do for you because then you will not be doing anything in this question. You put these values and tell
Sorry, sir.
me
Hello,
what
sir.
is the average speed coming as.
Hello.
Yes, beta.
Sir, sorry, sir. T2 equals to 3L by 5 V2, sir.
Oh, yes, not V1. I have also written V1. It is V2. Okay, just put the values of T1 and T2 and tell me what is the answer that we are getting. Don't worry about this L. This L is going to get cancelled out from everywhere. What is the value of average velocity, average speed that you are getting? Yes. Anyone got the answer?
D, sir.
D is correct. The answer will be 5 V1 V2 upon 3 times V1 plus 2 times V2. That is the answer that you will get doing all those things correctly. Do we understand this?
Yes, sir.
Anyone understands this? Okay, then I'll give you one that you can do and tell me the answer. It's coming on your screen just about now. I hope that all of you can do this.
Once can you give time to copy, sir?
Yes, bacha?
Sir, can you give time to copy?
Yes, yes, yes. You have not done the question?
Sir, but
Done, na? You need more time to see it's there on your screen. Just to know. Okay, you need more time to solve in the next question. That is what you're asking. Have you
No,
done this
sir.
question?
No, sir. He is saying that we have this answer, sir.
So answer, you did not get the answer. That is what you are saying. Sometimes this communication is a yes. Tell me, you did not get the answer. अरे say ना. Say.
Sir, he is saying that we have to copy that. You solve that question now. Question number 1. This
Okay.
one. That's sir.
Copy it. Once you are done, please let me know so that we can move forward in life.
Sir, completed, sir.
Okay. That takes me to the next question. And your time starts now. Remember, you don't have to write the entire question. Write the question in the shortest possible way. Write the question in terms of a diagram. As soon as you look at the question, start solving it with a diagram and get the answer. Because if you note down the entire question, then solve it, it will take a lot of time. Do you understand it? These are simple questions. You don't have to write the entire question. We understand this? Because if you take too much time in writing the question, beta, we will not be able to solve many questions in the class. The question comes now. It's there on your screens. A car moving on a straight road covers 1/3 of the distance with 20 km per hour and the rest with 60 km per hour. What is the average speed? Yes, anyone with an answer?
Sir, answer D.
Answer D, 36 km per hour. That is absolutely correct, my dear friends. That is absolutely correct. Well done. Everyone got the answer then? Okay. Shall we go and solve the question now, everyone? So how are we supposed to do this? As I said, first draw a representative diagram. You don't have to be very fancy. A, B. You don't know the total length of the path. You can call it as L. Total length is L. You take a point C somewhere from A to C. As you can see, the distance is given as L by 3, 1/3. So the rest of the distance becomes 2L by 3. Then you can, it's given that from here to here, He is moving with 20 kilometers per hour. I have not written the units. From here to here, he is moving with 60 kilometers per hour. I have not written the units. No space, no time. Let me call this time as T1. And let me call this time as T2. We all know the values of T1 and T2. What is the value of T1? From these three quantities, we'll get the value of T1. What is the value of T1?
Sir, L by 60.
T is L divided by 3 divided by 6 by 20. So L by 60, that is correct. From
T2.
here, you can get the value of T2. What is the value of T2? It is 2L by 180, yes or no?
By 9.
That will be L by 90. Once you have done this, you just have to put the formula for average speed. Total distance divided by total time. Total distance is L. Total time is T1 plus T2. You put both these values of T1 and T2 and you add and divide and subtract and multiply. You will end up with the average speed. And how much it is coming as? I think it is coming as 36 kilometers per hour. Yes or no?
Sir.
How many of you could do this? Only 1, 2, 3, 4. What about the rest? Great. That means this thing is done. I will give you one more. And I want the answer fast in this case. I hope you will be able to give me the answer fastest. Has everyone noted this down? Yes or no? No, yes.
Sir, 2 minutes.
2 minutes. Okay. 2 minutes रुक सकते हैं. Maggie can be made in 2 minutes. Meanwhile, you write, I will make a Maggie. Are we ready for the magic? Done, everyone? Then comes this one, and I need the answer first. A train has a speed of 60 kilometers for first 1 hour, 40 kilometers per hour for the next half hour. What is the average speed in kilometer per hour? Anyone with an answer?
Sir, B.
Sir, B. You said B, na? Or D?
Sir, option B.
Option B is absolutely correct. Draw a simple diagram. Follow the steps. C point. From A to C, he is moving with a speed of 60 kilometers per hour. From C to B, he is moving with a speed of 40 kilometers per hour. I mark it. From A to C, the time is 1 hour. From C to B, time is half hour. I don't know how much distance he has moved. It is very simple. Let me call this as L1. And let me call this as L2 or X2, whatever. From these two quantities, these three quantities, I can get the value of distance L1. Yes or no? How much will be distance L1 coming as? He's moving with 60 km per hour for 1 hour continuously. What will be the distance he'll move? Nothing. They say
60, sir.
60, sir. Correct, sir. Then he moves with 40 km per hour for half hour.
20.
So L2 will be equal to 20. Yes, my dear friends. Now I just put the formula. Total distance L divided by total time. Total distance L is L1 plus L2. Total time is 1 plus half. L1 is 60, put it here. L2 is 20, put it here. Solve them, which you have to do. I am not going to do it. Get the value of average velocity, and you are very correct. I think it is, why I written 36? It will come as 53.33. And that is the answer that we are looking at, my dear friends. 53.33 kilometers per hour. How many of you got this answer? Please raise your hands. Only 1, 2. Yes, I see you. 3, 4, 5. Only one center is getting the answer. The other center students, I don't know what they are doing. Yes. Okay. They are wondering. I see someone at the back of the class having water. See, I have an all-seeing eye. I can see everyone. I hope all of you are trying. I can see trials being done. That is the best part, that you are trying. Do you understand this? Yes or no? The concept of average speed. Now comes the next step, the next term that we are going to study. And my dear friends, tell me which is the next term that we should study at this point in time. What is the next thing? The next term is definitely velocity. Now, as soon as you hear about velocity, velocity is normally defined by V, and it is a vector quantity. Yes or no? So we write velocity as v vector. Now, as soon as you hear the term velocity, if I ask you the definition of velocity, what do you mean by, or what do you understand by velocity? What would you say?
The total displacement by total time taken.
That is not velocity. That is something else.
Displacement by time.
Displacement by time. No, not exactly correct. Try again. Velocity.
Displacement by time.
So that means speed
Change
is.
in displacement by time.
Yes, beta?
Change in displacement by time.
Change in displacement by time. Okay. Do we remember this?
Delta S by delta T.
Delta S by delta T. Okay. Everyone is trying. That is good. The best way to define velocity would be
Rate of change of displacement with respect to time, sir.
that is very near to correct. Rate of change of, we don't call it displacement, we call it PV. What is this PV?
Into velocity.
What is this PV?
Momentum.
Pressure into volume. No, it's not pressure into volume.
Momentum
PV.
into velocity.
Can you speak a bit louder, beta? Can't hear you. PV.
Change in velocity.
Change in velocity. Velocity is rate of change of velocity. That will not make sense, right? PV is, my dear friends, position vector. Do you remember something like position vector?
Yes, sir.
So it is
Yes,
the
sir.
rate of change of position vector with time. Now books will tell you that instead of this position vector, they will say rate of change of displacement with time. That is theoretically not correct. It is not said as rate of change of displacement with time. It is the rate of change of position vector with time. That is the correct definition of velocity. What type of unit it is? What type of quantity it is? It is a vector quantity. Do we understand this? Now, as soon as we say that it is vector, it must have two things. What are those two things?
Magnitude and direction.
Well done. Now we are talking. It will have both magnitude as well as direction. So whenever you think about vectors, think about these two quantities, magnitude and direction. What is the SI unit?
Meter per second.
Well done. What is the dimension?
LT minus 1.
Now we are talking. This is a brief introduction about velocity, and I hope everyone is noting this down. As soon as we are done with velocity, we will move into the types of velocity that we are going to encounter. Has everybody done this? Yes or no? Okay. Then I ask you, my dear friends, what do you mean by types of velocity? How many types of velocity are we going to study? What is the first one in that category?
Types of velocity.
Uniform velocity.
Uniform
sir.
velocity is correct. Uniform velocity. Uniform velocity is the first type of velocity that we are going to hear. Now, instead of uniform velocity, we can use other terms. What are the other terms that can be used in place of uniform velocity?
Constant velocity.
You can use constant, well done, or you can also use velocity remaining same. Do we understand this?
Yes, sir.
Same terms, doesn't matter. Now, as soon as you hear the term uniform velocity, Can you explain or can you tell me? Remember, I write everything in point-wise fashion so that it's easier for you to remember. Yes. How will you
Sir,
understand?
total displacements covered in total in equal intervals of time, sir. Equal displacements.
Equal
dis-
displacements, not total displacement.
Sorry, sir.
Equal displacement
In equal intervals of time.
in equal intervals of time. That is correct. Equal displacement in equal intervals of time. There is one more way to understand this, which is coming from the definition itself. Velocity remains
Constant.
same or constant. It cannot change. Now, whenever I say velocity remaining same, it is a vector, and a vector remaining same means it must remain same both in what? It must remain same both in what?
Magnitude and direction.
It must remain same both in magnitude plus the direction. If any of these things changes, we cannot call it uniform velocity. Do we understand this? Now, there is one more way of understanding this uniform velocity, which comes from its not real, far distant cousin, and is very far, very far distant cousin with whom we are going to relate is this gentleman. Now, can you tell me or can you try to explain that gentleman, the new gentleman, in terms of this gentleman, which is the older gentleman? How can you relate the two far brothers, not brothers, cousin brothers? How can you understand uniform velocity in terms of what I have just shown you? Yes? Anyone?
I think covering distances with equal time, sir.
That was uniform speed, beta. What have you added? You haven't added nothing. Okay. So this is how it goes. It means that the body is moving with uniform speed in. Now, can you complete the sentence? Same direction. Now, imagine what I said at the beginning of the class. I am on a bike and the speedometer of the bike always remains at 50, but I keep on turning here and there. That means I am moving with uniform speed, but since my direction is changing, I am not moving with uniform velocity. Now imagine another case where I have a straight road and I again keep the speedometer at 50 km per hour, and then I move in one straight line without changing direction also. If my speedometer always shows 50 km per hour, that means I'm moving with uniform speed in one particular direction, and that is what I call uniform velocity. So whenever someone is saying uniform velocity, he is talking about one very particular type of motion. Which type of motion is he talking about? Which type of motion? There's only one
Uniform
motion.
motion.
Yes?
Uniform motion.
Straight line.
Straight line. Yes. Straight line. So only this motion, of all the motion that we have read, only this motion is a straight line motion. 100% straight line. This is a motion in straight line. Do we understand this? Straight line with same speed. Straight line with same speed. This is the only type of motion which is straight line. In uniform speed does not mean straight line. Do we understand this? But uniform velocity definitely means that the motion has to take place in SL. What do you mean by SL?
Straight line.
It's not Sri Lanka. Straight line. That is correct. The motion has to happen in straight line. Do we understand this?
Yes, sir.
It has gone above our head saying bye bye. I'm going, sir. Don't worry about this. That was, my dear friends, uniform velocity. I hope all of you have written this. If you have understood uniform velocity, then the other gentleman automatically comes into the picture. And what is the next gentleman that jumps into the picture?
Non-uniform velocity.
Non-uniform velocity is the next character that we have to introduce. This is a movie. It's a big budget movie and there are a lot of characters. So now the next character enters is non-uniform velocity. As soon as we hear the term non-uniform, we can think of other terms which have similar meaning. And what is the other term which has similar meaning?
Variable velocity, sir.
Variable velocity. Yes. So if someone says variable velocity, then you can understand that he's talking about non-uniform velocity. How can you understand this? How can you define this non-uniform velocity? You can take the help of the other distant cousins that we have created.
Equal displacements in equal intervals of time, sir.
The easiest way or the simplest way will be unequal displacements in equal intervals of time. Do we understand this?
Yes, sir.
Sir.
Or there is another way of understanding this, which comes from the name of the character himself, itself, whatever. If you don't want to call him a him or a her, the name of the character itself. How can I understand uniform, non-uniform velocity from the name of the term itself? Yes. Velocity will keep on. Velocity is not
same.
not constant. That means it changes. Now, as soon as we hear the word changes, how it can change?
With magnitude and direction.
It can change in magnitude, it can change in direction, or it can change in both. Do we understand this? It can change in magnitude, it can change in direction, it can change in both. Now, can you give an example of a motion where it is only changing in magnitude? Can you think of a motion in which velocity is only changing in magnitude? It is not changing in direction. Yes. No one can think of. I have this sharpener, rubber, whatever it is. I throw it up in the air. When it is going up, slowly it is getting slower. Yes or no? But it is going in the same straight line. But its magnitude of velocity, its magnitude is changing. It is getting slower. Yes or no? But it is moving in the same direction. You are on a bike moving on a straight road and you apply brakes. You are in a car on a straight road and you apply brakes. The car will not change its direction, but it will change the magnitude of velocity. That is the example of velocity changing in magnitude but not changing in direction. Do we understand this?
Yes, sir.
Can you think of an example where velocity only changes in direction but does not change in magnitude? The example that I gave you, I'm on a bike, 50 km per hour, and I keep on moving here and there. The speed or the magnitude is constant, but the direction is changing. I am moving in a circular path with 50 kilometers per hour. The magnitude is constant, but the direction is continuously changing. Do we understand this?
Yes, sir.
What is the example of changing both? Any motion. I am on a bike and sometimes I'm 20, sometimes I'm 30, and then I am doing all sorts of stunts. I'm moving here and there. That is the example of velocity changing in magnitude as well as changing in direction. Do we understand this? Remember, the name of the chapter is motion in a straight line, but we have not confined ourselves to motion in a straight line. The definitions that we are doing are not confined to straight line. They are definitions of character themselves. Do we understand this? That
Yes,
was,
sir.
my dear friends, non-uniform velocity or variable velocity. I hope everyone has understood this. What is the third quantity that is going to come, my dear friends? Third type of velocity.
Average velocity.
Well done, average velocity. So once you understand the pattern, my dear friends, you have done well done. You have done nice. How will I represent average velocity? V,
Total displacements by total time taken.
and I put that dabba. The dabba means average. And how do I find this average velocity? When I asked you velocity, you said total displacement divided by total time. You were not actually defining velocity. You were defining this quantity, which is average velocity. Do we understand this? So this quantity is total displacement divided by total time. Do we understand this? Total displacement divided by total time. You come from home to school, to center. You move in different ways. You move with different speeds. If I draw a straight line from your home to your school, that will be your displacement. Yes or no?
Yes, sir.
And I divide it by the total time, I will end up with your average velocity. Do we understand this?
Yes, sir.
Now it is prudent that I write a formula for this. So average with a dabba, V with a dabba, that will be delta R vector divided by delta T. Do we understand the meaning of the term that I've used here?
Sir,
That is, my dear friends, our new friend, average velocity. Say hi to him, and he is going to come in many ways. And if we have good relations with him, for all the quantities that have come, then we are going to have a jolly little time. Else, they are going to trouble us a lot. Now, when we are talking about this average velocity, there must be magnitude and distance, magnitude and direction. If you have the vector of displacement, you can find the direction as well as magnitude. Just have to write one more thing, just to clarify things. What will be the direction of average velocity? Now, looking at the diagram, looking at the formula, can you tell me what will be the direction of average velocity? Because sometimes people, students get confused with what is the direction of average velocity. Yes, what is the direction of average velocity? You have come from home to school. I know your displacement. From home to school, I will draw a straight line vector, a straight vector. That will be your displacement, magnitude as well as direction. What will be the direction of your average velocity? Yes. What is the direction of average velocity? I'm waiting. Anyone with an answer? The direction of average velocity is same as the direction of your displacement vector. Do we understand this? As you can see, average velocity is total displacement divided by total time. One vector divided by a number. It is a vector divided by a number. and therefore its direction would be same as the vector which is getting divided. Do we understand this, or this has gone above our head saying bye bye bye? Sir, I'm going. I hope everyone has understood this. Yes or no?
Yes, sir.
Sir.
Average velocity. And remember, this average velocity is always calculated over an interval of time from here to there, from 5 seconds to 10 seconds, from home to school, from here to there. Average quantities are always done over an interval of time. Do we understand this? That was, my dear friends, average velocity, which was calculated over an interval of time. Then what is the next quantity which is not calculated at any time
Instantaneous
interval?
velocity.
And comes our last,
Instantaneous.
but not the least, the most important character in this movie.
Instantaneous velocity.
Instantaneous velocity. Instantaneous velocity. Everyone wants everything instantaneous. Instant noodles, instant this, instant that, instant cash withdrawal, instant cash transfer, instant this, instant message, instant Instagram, instant velocity, vibrant value, instant velocity, instantaneous velocity, v vector. And as soon as I write the same v vector here and the same v vector here, one thing is pretty damn clear, that whenever someone is talking about velocity, which velocity is he actually talking about? He is talking about?
Instantaneous velocity.
He is talking about your instantaneous velocity. He is talking about your instantaneous velocity. What is your velocity now when I'm asking you? So,
Velocity
what
at
is
any
instantaneous
instant.
velocity? Tell me what is the
Velocity at
definition.
any
It is the
instant.
velocity at any?
Instant.
It is the velocity at any instant. It is the velocity at any instant. Now I will try to derive or write a formula for it. dr vector by dt. That becomes the formula for instantaneous velocity. Do we understand this, my dear friends? And therefore I call it, rate of change of, see, rate of change is d by dt. It is d by dt of r. And r is your position vector. R is not your displacement vector. Therefore, this is known as rate of change of PV with time. This is not PV Sandhu. Then who is he or her? This PV is not pressure into volume, not PV Sindhu. I know she is very popular.
Position vector.
Position vector.
This is position vector with time. Do we understand this? Yes or
Yes,
no?
sir.
No, yes.
Yes, sir.
Well done, sir. Now, as soon as we think about instantaneous velocity, it is a vector, my dear friend. Yes or no?
Yes, sir.
It must have two things. One is
Magnitude
the
and direction.
magnitude, other is the direction. We'll talk about the direction in the next class probably. Let us talk about its magnitude. What is the magnitude of instantaneous velocity? Now, again, take an example. Let us imagine that you are on a bike, riding, or a car, driving, or sitting in a car, and then I call you and ask you what is your instantaneous velocity. I will not say instantaneous probably. I will just ask you what is the velocity right now, or what is the velocity, or what is your instantaneous velocity. How will you tell me your instantaneous velocity? Yes. Or will you say, sir, I will not talk because I am driving, because that is against law. So assume that you are not driving, you are sitting behind a driver.
By using a speedometer.
By using the speedometer, dear, you will only get the magnitude. And by using speedometer, you get the value of your instantaneous speed. Do we understand this?
Yes,
That
sir.
brings us to a very important fact, that the magnitude of instantaneous velocity, that the magnitude of your instantaneous velocity is your instantaneous speed. Do we understand this? The magnitude of instantaneous velocity is your instantaneous speed. So I can write this instantaneous velocity as instantaneous speed with direction of motion wherever you are moving. So right now, if you are in a car and your car is moving with 50 kilometers per hour, that 50 kilometers per hour is your instantaneous speed, or simply we call it speed. And if I put 50 kilometers per hour in the north direction, 50 kilometer per hour in the north direction becomes your instantaneous velocity. And that is why you might have heard this term, velocity is speed with direction. Have you heard this? That is only valid for instantaneous velocity. Do we understand this? So the magnitude of
Yes, sir.
instantaneous velocity is your speed. Now I will go back, since I have a time machine and I am more like Doraemon, Buddha Doraemon, obviously. And I asked you to make a star and leave some space here. Yes or no? Do you remember this? Or we are
Yes,
having all
sir.
blackouts? I said just make a star, we'll write something here. Now I ask you, what is that we are going to write here? Which we left 2 lines.
Sir, instant velocity in direction of motion.
Read that. Open your eyes, my dear friends. 4% of the universe is what we see. And that is beautiful. Trust me. 96% we might not see. Just what are we going to write here? Again, think. You are thinking right, but speaking wrong. And if you speak wrong, then your right thinking also becomes your wrong thinking. Yes. What are we going to write here? Instantaneous speech. Yes. What are we going to write? Say. Try. I'm not going
Scalar
to.
quantity.
Huh? I'm not.
Scalar quantity.
I'm not going to jump out of the screen. I am no leopard or cheetah that I'm going to jump out of the. I know cheetah has come in India, but that doesn't mean that I'm a cheetah and I'll jump out of the screen and grab you and take you back here. Can't do that, right? So don't be scared. Instantaneous speed. What I'm going to write here? Arey say. You were saying something. I lost it because I was becoming cheetah and coming out of the screen. Yes. Say. What I'm supposed to write in that star?
Scalar quantity.
So we have written so many times before also, yaar. Scalar quantity, speed is scalar. We have written in the very beginning. So there is nothing new in this. What is he new that we have just now read? There is a very famous movie, Gajni, which stars Amir Khan. And he has this habit of forgetting everything in 5 minutes. But that only looks good in a movie. And if we have this habit of forgetting everything in 5 minutes, well, we are not going to make a movie out of it. And that is not going to work anyways, because these days remakes don't work. Remakes do fall apart, and this movie was not an original production of Gajni. The original movie was known as Memento. It's beautiful movie. It was remade as Gajni, and we cannot make another Gajni here. So we should not forget what we have done just 2 minutes before. Yes. Anyone? What I'm going to write here? I've extended the time limit for the class. So I will just keep this as question mark, and I will again ask you to see what we have done 2 minutes before in the class and come back and tell me what we are going to write here. Because if I keep on helping you in remembering things, I might end up becoming a doctor rather than a teacher. And I like my teaching profession hell lot because I can't dissect things and take the kidney out and put another kidney in someone else's body. I don't do that. Okay, so this is still a question mark, and I will expect that you will tell me what is going to be written here. Yes or no? Okay, so on that bright note, let us rewind what we have done today. In today's class, we have encountered the next characters in the whatever movie, cinema, or whatever. In our physics journey, we have encountered velocity. We have encountered the types of velocity. In the next class, we will see some problems on this, and we will encounter the next character in this journey of ours. What is the next character called? Huh?
Acceleration, sir.
Relation, sir? What relation, sir?
Acceleration.
Acceleration, sir. Okay. We'll encounter acceleration and we'll see the types of acceleration, and then we will move on. Once acceleration has been introduced, we will be accustomed to all the characters in this particular chapter, and then we will look at some more equations and try to wind this chapter ASAP. If you have any doubts, please come up to me. Anything that you want, any doubts, please come up. Else, it's a wrap from my end. Stay healthy. May God bless you all. And before coming to the class, in the next class, please go through what we have done in this class, okay? Else, it is a total washout. Take care. God bless you.